Okay, we'll start now. Okay. ಟೆಸ್ಟ್ ಎಲ್ಲರೂ ಚೆನ್ನಾಗಿ ಮಾಡಿದ್ರಾ? ಕ್ವಶನ್ ಪೇಪರ್ ಹೇಗಿತ್ತು? ಹೇಗೆ ಅನಿಸ್ತು ನಿಮಗೆ? ಇಸ್ ಇಟ್ ಡಿಫಿಕಲ್ಟ್ ಆರ್ ಈಸಿ ಆರ್ ಮಾಡ್ರೇಟ್? ಕ್ವಶನ್ಸ್ ಹೆಂಗಿತ್ತಪ್ಪ ಟೆಸ್ಟಲ್ಲಿ? ಮಾಡ್ರೇಟ್. ಓಕೆ ಓಕೆ, ಗುಡ್. ಟಫ್ ಅಂತ ಏನು ಅನಿಸ್ಲಿಲ್ಲಲ್ಲ? ಓಕೆ. Okay, we will discuss from the classification of data structures. In the previous class, we had discussed the classification of the data structures. Okay, so here the data structures. Data structure is nothing but it is a systematic grouping of the data items in the memory. So we are systematically storing the data in our memory. Okay. So systematic grouping of data structure, we can classify that into primitive and data structure and non-primitive. So primitive means it includes the primitive data types like integers, real numbers, characters, logical data items, and pointer data types all comes under primitive data structure. So by using these primitive data items, we can construct non-primitive data structure. In the non-primitive data structures, they include arrays. Arrays is it may be group of integers or floating point numbers, group of real numbers, so like that. And then we have a list. List is again group of those. So therefore, we can say that non-primitive data structures. So here it is it is derived from the primitive data structure. So therefore, the files, arrays, list, trees, graphs, everything comes under non-primitive data structures. So so that we can classify those data structure into linear and non-linear data structures. This we had already discussed. So data structure is classified into primitive data structure, non-primitive. In that primitive, we have logical data items, integers, real numbers, characters, and pointers. And non-primitive arrays, list, files, trees, and graphs. Again, we can classify non-primitive into linear and non-linear. In linear, we have arrays, list, and files. In the arrays, we have stacks, queues, and linked lists. So they are linear data structures. And list, we have sequential, indexed, and there are sequential list, indexed list, and random list. There are three types of list and files. So these are the three data structures comes under linear. And here in our syllabus, we are discussing only we are discussing linear data structure with in that we are discussing only the arrays, and in that arrays we are discussing stacks, queues, and linked list. Okay, we are not discussing files and sequential, indexed, and random lists. In the non-linear data structure, we are discussing trees and graphs. And again, the trees are further classified as general tree and binary tree. Graphs are further divided into digraphs and undigraphs. So this is how the classification is done. So in the non-linear data structure, in our syllabus, we are discussing trees and graphs, everything here non-linear. But in linear data structure, we are only discussing the arrays. In that, we are discussing stacks, queues, and linked list. Okay. So non-primitive data structure derived from primitive data types. And okay. Then, for example, array consisting of integer elements. They are classified as non-primitive. So here the operation that can be done on non-primitive are, so here we can, for example, create or define an array or list or file. So these are linear data structures. So the arrays are arrays, list, and files are the linear data structure. We can do the operations like create and define an array, or creating the list, creating a file, etc. Search for any element in an array or the list, or we are locating the record for a record in a file. Okay. So these are the various operations that has to be done. So we have to write the algorithm to sort the elements of the array, are into descending and ascending order, or combine or merge two or more lists to form the another list, and insert elements into the array or into the list, okay, linked list, and delete the elements from the linked list or array, or it may be a any kind of list. It may be a random list or sequential list, or it may be an indexed list. So okay, so list we are not discussing. Only we are discussing the arrays. In that we are discussing stacks, queues, and linked list. Okay. So delete a node from the binary. If I consider the non-linear data structure, in that we are discussing how to traverse a tree. So what are the different types of traversing the tree, in order, post order, pre-order algorithms, and we are deleting the node and inserting a new node into the binary tree, and also we can search for a minimum the node which is having minimum value or maximum value. So like that we can do any operation. So if I consider the file, then we can do copy a file, update the file, or delete a file, etc. These are the operations that can be done on the data structure. Okay. In that we are discussing linked list. Okay. What do you mean by linked list? Okay. What is the pictorial representation of a linked list, and what are the different types of linked list we are discussing? So in the stacks and queues, okay. So when stacks and queues are nothing but, stack is a again set of memory locations. Set of memory location which here in the stack. So stack is first the first in first out. Here the last in first out. Stacks are always the last in first out. Okay. So that means whatever the element we put at the last, that has to be taken out first. Okay. So therefore stack operation. So stack and queue operation. In the queue, it is first in, first out. Okay. Queues are first in, first out means, so whatever the element we put first, that has to be taken out first. Okay. So queues are first in, first out, and the stacks are first in, last out. So they are all restricted list. We call them as a restricted list or arrays, because so the deletion and insertions are done at the only one end. Okay, only at the ends of the list. Okay, in the middle we cannot insert anything. We cannot delete anything in the middle. So inserting. So therefore they are inserting and deletions are restricted to occur at the end of the list. Okay, at the end of the queues and stack. So ಈ ಸ್ಟ್ಯಾಕ್ ಕ್ಯೂ ಅಲ್ಲಿ ಲಾಸ್ಟ್ ಅಲ್ಲಿ ಮಾತ್ರ ಇನ್ಸರ್ಟ್ ಮತ್ತೆ ಡಿಲೀಟ್ ಮಾಡ್ಬೋದು, ಅಥವಾ ಅಟ್ ದಿ ಅದರ್ ಎಂಡ್. Okay. So therefore in stacks and queues, all the items are kept sequentially in arrays, declaring a maximum size of arrays. Here we can declare what is the maximum size of the queue and what is the maximum size of the stack. That has to be defined. So therefore, whatever the items we want to store in the stack and queues, they has to store sequentially one by one. So we cannot increase the amount of storage allotted at the runtime. So we cannot increase the size of the stack or queues at the runtime. So therefore, it sometimes causes overflow if the stack become full, and then it becomes overflows. Okay, sometimes sometimes in the if the stack become full, it overflows. Okay, so that may be that situation may occur. Okay, so therefore these problems can be solved. Okay, by introducing new data structure called linked list. So by using linked list, we can solve these problems. So that means storage problems. Okay, so at the runtime only we can the storage can be increased, or it need not to be insertion deletion need not to be done at the end of the stacks and queue. In between also we can insert the node, or we can delete the node in between. So we have the nodes, for example, we call that as a node. Okay, node 1, node 2, node 3, node 4. So that means they are whatever the data stored in that particular nodes, so they are stored sequentially. Okay. For example, I want to delete or insert one more node in between, or at the end, or at the front end, or at the rear end. So then we can insert at any time. So therefore, a linked list is a series of data items with each item containing a pointer giving the location of the link item in the list. So that means a linked list is a series of data items. The data items are stored and each item containing a pointer. So there is a pointer variable which links to the next item. Okay, location of the link item in the list. Okay, so we can place the elements anywhere in the memory. It need not to be a consecutive memory location. So we can store the elements or the data items anywhere in the memory. But to make them part of the same list, it is required to be linked with the previous element of the list. That means in a particular node, so we are storing the data items and also it holds the address of the next node where we are going to store the next item. Okay, next data item. So therefore, each node holds both data items as well as the pointer which points to the next node which holds the next data item and the next so therefore it becomes second node. Similarly, the second node holds its own data items and it also holds the pointer address or the pointer variable to address it holds the address of the next node. Okay, so that we can it is like virtually connected. Okay, okay, and that means logically connected. It is a logically connected. So therefore uh, so we it is so therefore the elements can be stored anywhere in the memory, but we need to give the link any address. So in the memory available in the any address, it can be stored, the data items are stored, but there is a link between the all the nodes. So therefore, here to make them a part of the same list, it is required to be linked with the previous element of the list. So therefore, previous element and the next elements are linked. So this can be done by storing the address of the link element in the previous element itself. Okay, this is what I said. So we are storing the address of the link element in the previous element. That means link element means in the we are storing the address of the next node in the first node only, so that it will link that to that node. Again, the second node will hold the address of the third node, so that there will be a link. So this requires that every element must be capable of holding the data as well as the address of the link element. Here I am calling this as a link element. Okay. So or we call it as a totally we call it as a node. In a node holds both data items and the link element or the link address. So therefore, every data element called nodes must be a record with a minimum of 2 fields. Okay. So node, therefore, it consists of 2 fields, one for holding the data value, that is information. Information may be the information andre the data items means it may be integer numbers or floating point numbers or characters, anything, the data value holded by that particular node, and that we call it as a data field or information field, and the other for holding the address of the link element, which we call it as a linked field. So therefore, a particular node consists of both the data field and the link field. Okay. So this next slide, it shows the pictorial representation of the linked list. So here we are discussing the single linked list, single or singly linked list, double linked list or doubly linked list. Okay. So therefore, here we can represent the linked list like this. So memory representation of single linked list or the pictorial representation here. This memory, that means here, for example, this is a first node. Okay. Let us consider this is a first node. So in that we have both field, information field and linked field. So this first node address is 1004. Okay. So let us assume that the address of the first node is 1004. And this in the 1004, we have stored the information 50. 50 is, for example, one number we have stored. So in the location 104, we have stored 50. And also the link address. Okay. Link address means 1020. So which is the address of the next node. Here you can observe 1020 is the address of the next node. This node, second node. So second node address will be stored as a link here. Okay. So that it is linked, second node is linked to the first node. Okay. Then in the second node, we have data items 20. And next we have a link field. In the link field, I have the address of the third node. Okay. This is a third node. And the address of third node is 1012. And that is stored in link field of the second node. So that this node is linked with this node. Okay. Similarly, the memory address. For example, here these memory addresses are not consecutive memory locations. They are different. So therefore, we are not using consecutive memory locations like stacks and queues. Here the linked list can be stored. The data items can be stored anywhere, but they are linked together. The nodes are linked together. So this is a pictorial representation here. Info field, link field. This becomes one node. Okay. So here memory address. The node is the starting address of this node is 1004. Starting address of this node is 1020. Starting address of this is 1012 and so on. So here 1004. 1004 holds the in whatever the information present. So whatever the information present in this particular node is present here. Okay. So it may be information, maybe anything. It need not to be a single number. Okay. It can be characters, floating point numbers, or integer, anything. So whatever the memory required for storing those numbers start with 1004. Okay. And next node starts from 1020. So that address is stored in link field of this node, so that it is logically linked to this node. Okay. And the starting address of this node is 1020. So in that I am storing in the information field, I am storing the number 20. It need not to be 20, anything. Okay. Any information. So it may be floating point number, characters, integer, everything will be stored here. So similarly, the node 3 and node 4. And now this is a pictorial representation, so that here the first node, it holds the value 50 in the information field. It has only number 50. And then it is in the link field, it is linking the second node. Okay. So linking the second node means this address has to be stored here. Okay. 1020 is the address of the memory. It's address of the memory location where the node 2 is stored, and this address has to be should be present in the link field of this node. Okay, this is a link field. This is a information field. Similarly, for node 2, so we have information present in the info field is only 20. And in the link field, I have to store the address of this node, which is 1012. So link field holds the 1012. So this is how we can connect. And at the end, if this is a end node, there is no address in the link field, because further there are no nodes. Only this is the last node. Then it consists of the link field of the last node always consists of null. Okay, null has to be stored at the end of the last node of the linked list. So last node and the link field of the last node is always null. Okay. This is the pictorial representation. If you understand this pictorial representation, then it is easy for you people to write the the algorithms or the programs, okay, related to this linked list. Okay, I hope all of you got this. Okay, then the memory, this is nothing but what I had explained already. So this list contains 4 nodes, and each node consists of 2 fields, info and link. The first field of each node is info, contains the data that has to be stored in the list. And this already we have discussed. This is a info field. Info field consists of data items. And then in this list, the data items 50, 20, 45, 10s are stored. Here are 50, 20, 45, and 10 are the data items that are stored in 4 nodes. Okay, that in the info field of the nodes. Okay. The second field, that is link of each node, contains address of the next node. So it consists of the address of the next node. Note the arrow originating from link field of each node. ಇದನ್ನ ನಾವು arrow ಇಂದ represent ಮಾಡ್ತಿದೀವಿ. So you can observe the arrow is originated from link field of the nodes. Okay, here you can observe. So that means after this node will come. That is the representation. Okay. So, but you can observe the memory location. They are not consecutive memory locations. In wherever we want, we can store the our data items. Okay. Then this arrow indicates the address of the next node is stored. So using link field, any node in the list can be accessed since the nodes in the list are logically adjacent. So they are not physically adjacent, they are logically adjacent. The link field, any node in the list can be accessed. Okay. Any node can be accessed since the nodes in the list are logically adjacent. So nodes that are physically adjacent need not to be logically adjacent in the list. Okay. So here, for example, these 2 nodes, okay, the first node and second node are physically adjacent, but they need not to be logically adjacent. We can here I have written physically they are adjacent. I may write the link address here 1012. If I write 1012, then this node will be connected to this third node. Okay, if I write this address, so they are logically connected, logically adjacent. Okay, so therefore here, so nodes are physically adjacent, need not to be logically adjacent the list. For example, nodes identified by the address 1004, 1020, 1012, and 1008 are physically not adjacent, but they are logically adjacent. Okay. So all these nodes are not physically adjacent, means they are not consecutive. We are not storing it in the consecutive memory locations. Okay. So they are somewhere in the memory, but they are logically adjacent. So therefore, in this list, the variable first contains the address of the first node. So here the first is a variable. So this consists of the address of the first node. Okay, we can make the first as a variable, and we can store the address of the first variable as 1004. Okay, so here address of the first node. Before creating the list, first should be initialized to null. So first, first before creating the list has to be created by the user. Okay. So before creating the list, we have to initialize that with the null, because there is no nodes present until the user creates it. So in order to create the linked list, so the user has to create it. Okay. Okay. User has to create the list. So therefore, the first should be initialized to null, indicating the list is empty to start with. So once the list is created, variable first contains the address of the first node. So if I consider first is a variable, so first variable always holds the address of the first node. Okay. The nodes in the list can be accessed using a pointer variable, okay, which contains the address of the first node. So, okay, the nodes in the list. For example, a list consists of 5 nodes. Okay, 5 nodes, and we can use a pointer variable, which that pointer variable can be created, and that pointer variable holds the address of the first node. If the first points to null, it means that the list is empty. Okay. If the pointer it is pointing to the null node, null. If it is pointing to the null, then there is no list created, or the list is empty. So then what are all the components of a linked list? So in the we already discussed, it consists of nodes, link field, and the data field, and then null pointer, external pointer, empty list. What do you mean by that? So nodes are nothing but a linked list is a non-sequential collection of data items called nodes. Here it need not to be sequentially. They are the linked list is a non-sequential collection of data items. Okay. These nodes have two fields called data field and link field. Already discussed, we have the data field and the link field. Then data field contains the actual value to be stored and processed. So in the data items, we are actually storing the values. Values may be the integer values, floating point numbers, or characters. Everything will be stored in data fields. Link fields means it is used to access a particular node and also known as pointer. In the link field, we store the address of the next node. So are the address of the node to which it is connected next. Okay. So next item, next data item. So then null pointer. What do you mean by null pointer? The link field of the last node contains 0 rather than a valued address. Because it is a last node, there is no node present after that particular node. Therefore, in the link field, we have to fill the null so that it represents the end of the node or end of the linked list. So it is known as valued a null pointer and indicates the end of the valid. That is the spelling mistake agide. It is known as valued a null. It is known as null pointer. It is known as null pointer and indicates the end of the list. What do you mean by external pointer? This points to, it always points to very first node in the linked list. The external pointer, that means the user declares that pointer, that external pointer, it always points to the first node in the linked list. Then what do you mean by empty list? The empty list with no, here the list is list with no nodes. That means there is no nodes present. So that we call it as empty list or null list. So there it is also called null list and empty list. Then what are all the operations we can do on this linked list? So the operations can be done are, the basic operations are create. So we can create our own linked list with one or more nodes and their information field is initialized with some value. Okay. Some values, not it is not same value, some value. Okay. So that means we are initializing the information field with some value and we can create any number of nodes in that linked list. Okay. So therefore, so we can create a linked list, our own linked list with one or more nodes. Okay. And their information field should be initialized with some value. Okay. And then another operation we can do is insert. Okay. So if the linked list is existed, we can insert a node into a new node into the existing list. Okay. So the insertion can be done at the front of the list, rear end of the list, and at the specified position in the linked list. This operation is termed as place. Okay. So that means, so anywhere we can insert our node. It may be at the front of the linked list or at the rear end means at the other end. Okay, front end and at the other end or rear end of the list and specified position in the linked list or any position. Okay, at the middle of the list we can insert the node. Okay, so therefore But in case of stacks and queues, it is not possible. To insert at the specified position is not possible. So because their insertion operations are they're sequential. So that means at the end only we can do the insertion and deletion operation. Okay. Then delete. So delete is used to delete the node from the existing list. We can delete a particular node. The node can be deleted from front of the list. Okay, front of the list or at the rear end of the list. Okay, and from the specified position in the list. So it is similar to insertion. Insertion ಹೇಗೆ ಮಾಡ್ತೀರಾ ಅಲ್ಲಿ similarly you can delete the number nodes. Then what do you mean by traverse? So traversing means it is nothing but visiting all the nodes of the list. Forward traversing and backward traversing. There are two types. So that we can write the algorithm for forward traversing or backward traversing, or we can write the program for that. So it refers to traveling the list from first node to last node. Forward traversing means traversing from first to last. Backward means traversing from last node to first node. So that can also be done. So therefore, we can do traversing in the forward direction or in the backward direction. These are the various operations that can be done on linked list. Okay. Then other operations are like search. So we want to search a particular data item in a data structure. So here search is used to search whether a given data item is present in the list or not, present in this particular data structure, which is nothing but a linked list. Linked list is a data structure which is a linear data structure, and we want to search a particular data item whether it is present or not in that particular particular linked list. Then concatenate. Concatenate means, so here used to appends or joins a second list at the end of the first list. So two linked lists can be joined. They can be concatenated. Okay. So therefore, concatenation operation can be done. Then display. Display means we want to display all the data items of the linked list. So then we can do display operation. Then sorting. Sorting operation means, so here whatever the elements present in the linked list can be arranged in ascending or descending order. Here it is similar to in the arrays and queues also we can do these operations, that is ascending, descending order operation, arranging the elements in the ascending or descending order in the arrays and also in stacks and queues also. Then reverse. So reverse operation is used to reverse the linked list. So whatever the data items present or data elements present, those elements can be, so here they can be reversed. Printing means we can print the content of the linked list. Then decompose is used to decomposition of a linked list into two even and odd linked list. That means how we can concatenate two linked lists. That means we're adding two linked lists. Similarly, we can separate it. We can decompose it. The linked list can be decomposed into odd and even linked list. Okay, we can separate it. Then which are the different types of linked list used? The singly linked list, doubly linked list, then circular linked list, and non-integer or non-homogeneous linked list. Okay. So here we are discussing single linked list, double linked list, and circular linked list. And the last one we are not discussing that, non-integer and non-homogeneous. So only the first three. In that we are discussing few programs on this. Okay. Example programs on single linked list and double linked list. Okay. Then what do you mean by singly linked list? So in the singly linked list, nodes linked together by a single pointer and can be traversed only in the forward direction. So that means here we have info field, link field, info field, link field. So these 50, 20, 45, 10 are the data items. And this link field holds the address of the second node. And this link field holds the address of third node and so on. So this has two ends, that is front end. This is a front end and this is the last end. Okay. Or we call it as a rear end. Rear end or the last node. Okay. Next we have the doubly linked list. In the doubly linked list, adjacent nodes are linked by two pointers, a left pointer and a right pointer. The right pointer will point to the next node, whereas the left pointer will point to the previous node. So here we have in the linked field, so it has two addresses. One is for forward address, another and here forward address, and another one is the previous node address. Both are present in the double linked list. In the double linked list, the node consists of both the address of the next node as well as address of the previous node. Okay, so that we call it as double linked list. Double linked list can be traversed in both forward and backward direction. Therefore, since it consists of both a particular node consists of both the address of the next node and the previous node, so the traversal can be backward or forward. Okay, it can point to the previous node or it can point to the next node. So therefore, double linked list can be traversed in both forward and backward directions. And locate given node predecessor and successor. Okay, so we can locate the node with predecessor and successor. That means which is the node comes after and which is the node comes before. So that can be located. And then is the circular linked list. Okay, so in the linked list, the link field of the last node contained a null pointer. So ಈ ಲಿಂಕ್ ಲಿಸ್ಟ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಸಿಂಗಲ್ ಲಿಂಕ್ಡ್ ಲಿಸ್ಟ್ ಅಲ್ಲಿ ದ ಎಂಡ್ ನೋಡ್ ಅಲ್ಲಿ ಅಥವಾ ರೇರ್ ಎಂಡ್ ನೋಡ್ ಅಲ್ಲಿ ಅಥವಾ ಲಾಸ್ಟ್ ನೋಡ್ ಅಲ್ಲಿ ನಿಮಗೆ ನಲ್ ಪಾಯಿಂಟರ್ ಇರುತ್ತೆ. ದಟ್ ಇಂಡಿಕೇಟ್ಸ್ ದಟ್ ಇಸ್ ದ ಎಂಡ್ ಆಫ್ ದಿ ಲಿಂಕ್ಡ್ ಲಿಸ್ಟ್. But in case of circular linked list, it holds the address of the first node. The link field of the last node of a linked list, it contains the address of the first node. So therefore it becomes circular. Okay. So we can modify the linked list by storing address of the first node in the link field of the last node. The link field ಅಲ್ಲಿ last node link field ಅಲ್ಲಿ address of the first node ಇಟ್ಬಿಟ್ರೆ it becomes a circular. The resulting list is circular list. From any point in such a list, it is possible to reach any other point in the list. So therefore, since it is a circular linked list, so we can reach any point in the list. A circular linked list does not have a first or last node. So therefore, circular list doesn't have any first node and last node. We must therefore establish a first and last node by convention. So by convention, we can do that. We have to identify that. A circular list can be used to represent a stack or a queue. Circular list can also be used to represent the stack or a queue. And circular list can be of singly linked list or double linked list. Again, that means circular list can be single or it can be double. Okay. Then we have a pictorial representation of the circular list. So it is like a ring. Okay. Here it will connect back to the first node. The last node, node 4, connects back to the first node. Okay, ನಿಮ್ಗೆ ಊಟ ಟೈಮ್ ಆಗುತ್ತಲ್ಲ, ಐ ವಿಲ್ ಸ್ಟಾಪ್ ಅಟ್ ದಿಸ್ ಪಾಯಿಂಟ್. ಸೊ ನಿಮ್ಗೆ ಏನಾದರೂ ಬೇರೆ ಎನಿ ಇಶ್ಯೂಸ್ ಅರ್ಥ ಆಗ್ತಿದೆಯಾ ಹೇಳ್ತಾ ಇರೋದು? ಏನಾದ್ರು ಡೌಟ್ಸ್ ಇದೆಯಾ ಇಷ್ಟರಲ್ಲಿ? ಎನಿಥಿಂಗ್, ಎನಿ ಡೌಟ್ಸ್?
ಎಕ್ಸ್ಕ್ಯೂಸ್ ಮಿ ಮ್ಯಾಮ್.
ಹೇಳಪ್ಪ, ಹೇಳಿ.
ಮ್ಯಾಮ್, ಡಬ್ಲಿ ಲಿಂಕ್ಡ್ ಲಿಸ್ಟ್ ಅಲ್ಲಿ ಬರೀ ಎಂಡ್ ಟು ಎಂಡ್ ಲಿಂಕ್ ಆಗಿರತ್ತಷ್ಟೇ. ಬಟ್
ಇಲ್ಲ, ಒಂದ್ ನಿಮಿಷ ಇರಿ, ಹೇಳ್ತೀನಿ ನಾನು. ಈ ಡಬಲ್ ಲಿಂಕ್ಡ್ ಲಿಸ್ಟ್ ಇದೆಯಲ್ಲ, ಇದರಲ್ಲಿ 3 ಫೀಲ್ಡ್ ಇರುತ್ತೆ. ಈಗ ನಾನು ಇದರಲ್ಲಿ 2 ಫೀಲ್ಡ್ ತೋರಿಸಿದ್ದೀನಲ್ವಾ, ಅದರಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಲಿಂಕ್ ಫೀಲ್ಡ್, ಆಮೇಲೆ ಇನ್ಫೋ ಫೀಲ್ಡ್, ಆಮೇಲೆ ಮತ್ತೆ ಲಿಂಕ್ ಫೀಲ್ಡ್ ಇರುತ್ತೆ. 3 ಫೀಲ್ಡ್ ಇರುತ್ತೆ. 3ರಲ್ಲಿ ಮಧ್ಯದಲ್ಲಿ ನೀವು ಡಾಟಾ ಐಟಮ್ಸ್ ಹಾಕ್ತೀರಾ. ಇನ್ನೊಂದು ಲಿಂಕ್ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಅಡ್ರೆಸ್ ಆಫ್ ದಿ ನೆಕ್ಸ್ಟ್ ನೋಡ್ ಇರುತ್ತೆ. ಈ ಕಡೆ ಲೆಫ್ಟ್ ಅಲ್ಲಿ ಇರುತ್ತಲ್ಲ ಲಿಂಕ್ ಫೀಲ್ಡ್, ಅದರಲ್ಲಿ ಅಡ್ರೆಸ್ ಆಫ್ ದಿ ಲೆಫ್ಟ್ ನೋಡ್ ಇರುತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಲ್ಲಿ 3 ಫೀಲ್ಡ್ ಇದೆ ಅನ್ಕೊಳ್ಳಿ. ಈ ಲಿಂಕ್ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಇದ್ರದ್ದು ಅಡ್ರೆಸ್ ಇರುತ್ತೆ. ಇನ್ನೊಂದು ಲಿಂಕ್ ಫೀಲ್ಡ್ ಇದ್ರೆ ಈ ಲಿಂಕ್ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಇದ್ರ ಅಡ್ರೆಸ್ ಇರುತ್ತೆ. ಸೊ ಅದು ನಾನು ಪಿಕ್ಟೋರಿಯಲ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಅಲ್ಲಿ ನಿಮಗೆ ಅದು ಕರೆಕ್ಟಾಗಿ ಬಂದಿಲ್ಲ. ಒಂದು ನಿಮಿಷ, ಅದನ್ನ ನಾನು ಬೇರೆ ತರ ತೋರಿಸಿದ್ದೀನಿ ಅಷ್ಟೇ, ಡಬಲ್ ಯಾರೋ ತರ ತೋರಿಸಿದ್ದೀನಿ. ಈಗ ನೋಡ್ 1 ಅಲ್ಲಿ 3 ಫೀಲ್ಡ್ ಇರುತ್ತೆ. ಬೇಡ, ನೋಡ್ 2 ತಗೊಳ್ಳಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೋಡ್ 2, ಇದರಲ್ಲಿ 3 ಫೀಲ್ಡ್ ಇರುತ್ತೆ ಅನ್ಕೊಳ್ಳಿ. ಒಂದು ಡಾಟಾ ಐಟಮ್ ಸ್ಟೋರ್ ಮಾಡೋಕ್ಕೆ, ಇನ್ನೊಂದು ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಇದ್ರ ಅಡ್ರೆಸ್ ಇಟ್ಕೊಳ್ಳುತ್ತೆ, ಇನ್ನೊಂದು ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಇದ್ರ ಅಡ್ರೆಸ್ ಇಟ್ಕೊಂಡಿರುತ್ತೆ. ಸೊ ದೇರ್ ಆರ್ 3 ಫೀಲ್ಡ್ಸ್ ಇನ್ ದ ಡಬಲ್ ಲಿಂಕ್ಡ್ ಲಿಸ್ಟ್. ಸೊ ದಟ್ 2 ಲಿಂಕ್ ಫೀಲ್ಡ್ ಇರುತ್ತೆ, ಒಂದು ಡಾಟಾ ಐಟಮ್ ಇರುತ್ತೆ, ಡಾಟಾ ಫೀಲ್ಡ್ ಇರುತ್ತೆ. ಸೊ 2 ಲಿಂಕ್ ಫೀಲ್ಡ್ ಏನ್ ಮಾಡುತ್ತೆ, ಒಂದು ನೆಕ್ಸ್ಟ್ ನೋಡ್ ಅಡ್ರೆಸ್ ಇಟ್ಕೊಳ್ಳುತ್ತೆ, ಇನ್ನೊಂದು ಪ್ರೀವಿಯಸ್ ನೋಡ್ ಅಡ್ರೆಸ್ ಇಟ್ಕೊಂಡಿರುತ್ತೆ. ಸೊ ದೇರ್ ಫೋರ್ ವಿ ಕ್ಯಾನ್ ಟ್ರಾವರ್ಸ್ ಇನ್ ಬೋತ್ ಡೈರೆಕ್ಷನ್. ಫಾರ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲೂ ಟ್ರಾವರ್ಸ್ ಮಾಡ್ಬೋದು, ಬ್ಯಾಕ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲೂ ಟ್ರಾವರ್ಸ್ ಮಾಡ್ಬೋದು. ಓಕೆ, ಅದೇ ತರ ಸರ್ಕ್ಯುಲರ್ ಲಿಂಕ್ಡ್ ಲಿಸ್ಟ್ ಅಲ್ಲಿ ಇಲ್ಲಿ ನಲ್ ಇರುತ್ತಲ್ವಾ, ನಿಮ್ಗೆ ಲಾಸ್ಟ್ ನೋಡ್ ಅಲ್ಲಿ ನಲ್ ಇರುತ್ತೆ, ಬಟ್ ಸರ್ಕ್ಯುಲರ್ ಅಲ್ಲಿ ನಲ್ ಇರಲ್ಲ. ಈ ದಿಸ್ ಲಿಂಕ್ ಫೀಲ್ಡ್ ಆಫ್ ದಿ ಲಾಸ್ಟ್ ನೋಡ್ ಹೋಲ್ಡ್ಸ್ ದಿ ಅಡ್ರೆಸ್ ಆಫ್ ದಿ ಫಸ್ಟ್ ನೋಡ್. ಓಕೆ, ಅದಕ್ಕೆ ಅದ್ರಲ್ಲೂ ಸರ್ಕ್ಯುಲರ್ ಲಿಂಕ್ಡ್ ಲಿಸ್ಟ್ ಅಲ್ಲೂ ನಿಮಗೆ ಡಬಲ್ ಸಿಂಗಲ್ ಇರುತ್ತೆ. ಸೊ ಡಬಲ್ ಸಿಂಗಲ್ ಅಂದ್ರೇನು, ಸಿಂಗಲ್ ಸರ್ಕ್ಯುಲರ್ ಲಿಸ್ಟ್ ಅಂದ್ರೆ ಇದೆ, ಇಲ್ಲೇನಿದೆ ಈ ಲಿಸ್ಟ್ ಇಲ್ಲಿ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಒಂದು ನಿಮಿಷ, ಇಲ್ಲಿದೆಯಲ್ಲ ಈ ತರ ಇಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಮಾಡಿದೀನಲ್ಲ, ಇಲ್ಲಿ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ನಲ್ ಇಲ್ಲಿ ಸ್ಲಾಶ್ ಹಾಕಿದೀನಲ್ಲ, ಇಟ್ ರೆಪ್ರೆಸೆಂಟ್ ನಲ್ ಅಂತ. ಸೊ ಇಲ್ಲಿ ನಲ್ ಇರಲ್ಲ. ಸೊ ದಿಸ್ ಅಡ್ರೆಸ್ ಹೋಲ್ಡ್ಸ್ ದಿ ಅಡ್ರೆಸ್ ಆಫ್ ದಿಸ್ ಫಸ್ಟ್ ನೋಡ್ 1004 ಇಲ್ಲಿ ಇರುತ್ತೆ. ಇಲ್ಲಿ ನಾನು ನಲ್ ಅಂತ ಹಾಕಿದೀನಲ್ವಾ, ಸರ್ಕ್ಯುಲರ್ಗೆ ಇಲ್ಲಿ ನಲ್ ಇರಲ್ಲ, 1004 ಇರುತ್ತೆ. ಅವಾಗ ಇಟ್ ಬಿಕಮ್ಸ್ ಸರ್ಕ್ಯುಲರ್. ಅದೇ ತರ ಡಬಲ್ ಲಿಂಕ್ಡ್ ಲಿಸ್ಟ್ ಅಲ್ಲಿ ಸರ್ಕ್ಯುಲರ್ ಆಗ್ಬೇಕು ಅಂದ್ರೆ ಅದೇ 3 ಫೀಲ್ಡ್ ಇರುತ್ತೆ. ಇಲ್ಲಿ ಎರಡೆರಡೇ ಇದೆ. ಸಿಂಗಲ್ ಲಿಂಕ್ಡ್ ಲಿಸ್ಟ್ ಅಲ್ಲಿ 2 ಫೀಲ್ಡ್ ಇರುತ್ತೆ, ಡಬಲ್ ಲಿಂಕ್ಡ್ ಲಿಸ್ಟ್ ಅಲ್ಲಿ 3 ಫೀಲ್ಡ್ ಇರುತ್ತೆ. ಸೊ 3 ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಸೊ ದ ಲಾಸ್ಟ್ ನೋಡ್ ಲಿಂಕ್ ಫೀಲ್ಡ್ ಫಸ್ಟ್ ನೋಡ್ ಕನೆಕ್ಟ್ ಆಗಿರುತ್ತೆ ಅಷ್ಟೇ. ಈಗ ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ಇದು ಒಂದೇ ಈ ಸಿಂಗಲ್ ಲಿಂಕ್ಡ್ ಲಿಸ್ಟ್ ಅಲ್ಲಿ ಒಂದೇ ಡೈರೆಕ್ಷನ್ ಆಗುತ್ತೆ, ಬ್ಯಾಕ್ವರ್ಡ್ ಆಗಲ್ಲ, ಫಾರ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಮಾತ್ರ ಆಗುತ್ತೆ. ಬಟ್ ಇನ್ ಡಬಲ್ ಲಿಂಕ್ಡ್ ಲಿಸ್ಟ್ ಬೋತ್ ಫಾರ್ವರ್ಡ್ ಅಂಡ್ ರಿವರ್ಸ್ ಡೈರೆಕ್ಷನ್ ವರ್ಕ್ ಆಗುತ್ತೆ, ಟ್ರಾವರ್ಸಿಂಗ್. So that means we can search in a backward direction, we can search for an element in a forward direction. That can be done. Insert ಮಾಡಬೇಕಾದ್ರೂ ಅಷ್ಟೇ, ಸಿಂಗಲ್ ಲಿಂಕ್ಡ್ ಲಿಸ್ಟ್ ಅಲ್ಲಿ ಇನ್ ಬಿಟ್ವೀನ್ we can insert, which cannot be possible in stacks and queues. Okay, we'll stop at this point. ಅದು ನಿಮಗೆ ಪಿಕ್ಟೋರಿಯಲ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಹಾಕ್ತೀನಿ. ಅದು ಡಯಾಗ್ರಾಮ್ ಸ್ವಲ್ಪ ಪೇಸ್ಟ್ ಮಾಡೋಕ್ಕಾಗಲಿಲ್ಲ PPT-ಗೆ. ಓಕೆ, ಎನಿ ಡೌಟ್ಸ್? ಇನ್ನೇನಾದ್ರು ಡೌಟ್ ಇದೆಯಾ? ಇರೋ ಏನು ಅನುಭವ್, ಒಂದು ಸ್ವಲ್ಪ ಇದು ನನಗೆ ಸ್ಕ್ರೀನ್ ಶಾಟ್ಸ್ ತಗೊಂಡು ಕಳಿಸ್ತೀರಾ ನನ್ನ ವಾಟ್ಸಪ್ಗೆ, ಇದು ಎಷ್ಟು ಜನ ಇದ್ದಾರೆ ಅಂತ. 59 ಅಂದರೆ 58 ಏನೋ, ನನ್ನ ಬಿಟ್ಟು 58 ಇದ್ದೀರಾ ಅಲ್ವಾ, ಅಥವಾ 57 ಆಗುತ್ತೆ ಅನ್ಸುತ್ತೆ, ಎರಡು ತೋರಿಸುತ್ತಿದ್ದು. ಸೊ ಟೋಟಲ್ 57. ಓಕೆ, ಅವ್ರ ಸ್ಕ್ರೀನ್ ಶಾಟ್ ತಗೊಳ್ಳೋ ತನಕ ಇರಿ, ಆಮೇಲೆ ದೆನ್ ಯು ಕ್ಯಾನ್ ಲೀವ್ ದ ಮೀಟಿಂಗ್. ಓಕೆ, ಇನ್ನೇನಾದ್ರೂ ಡೌಟ್ ಇದೆಯಪ್ಪ? ಯಾರಿಗಾದ್ರೂ ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ ಹೇಳ್ತಾ ಇರೋದು? ಅನುಭವ್ ಆಯ್ತಾ ತಗೊಂಡು ಸ್ಕ್ರೀನ್ಶಾಟ್?
1 minute.
ತಗೊಂಡ್ರಾ? ತಗೊಂಡೆ ಅಂತಂದ್ರೆ ನಾವು ವಿ ಕ್ಯಾನ್ ಲೀವ್. ಡೌಟ್ಸ್ ಏನಿಲ್ವಾ ಯಾರಿಗೂನು? ಟೆಸ್ಟ್ ಎಲ್ಲಾರ್ಗು ಮಾಡ್ರೇಟ್ ಆಗಿತ್ತಾ? ಅಭಿಜಿತ್ ಅವ್ರಿಗೆ ಮಾಡ್ರೇಟ್ ಅಂತ ಆಗಿದೆ. ಬೇರೆಯವ್ರಿಗೆ ವಾಟ್ ಅಬೌಟ್ ಅದರ್ಸ್? ಟೆಸ್ಟ್